Right, welcome back guys to Mwindambira Academy, home of mathematics, biology and chemistry. So here we are going to cover some of the questions asked by the Zimsec. And specifically in this video, we are going to have some solutions which were expected by the Zimsec standards for the O-level Zimsec chemistry June 2025 paper 2 on section A. And right, we are going to cover just two questions, right, which I am going to show you the expected solutions for the paper. Right, I know some of you guys you were like, I'm not going to make it, maybe in November, maybe you are doubting yourself, but I trust you guys. You are going to make it, right? You just need to follow what I'm going to share with you. So right, let's start. So the first question for the question 1, it was saying name the method used to separate a mixture of. Right, for the first one, it's a mixture of sand and salt solution. Right, so this brings us to the topic of separation of mixtures. Right, so if we see sand is a solid substance, but salt solution is dissolved, which means it's in liquid form. So which means we are going to separate a liquid and some solid particles. So right, so we are going to use the filtration method. So that's the solution for the first one, is filtration. Because when we use a filter paper and a beaker, we pour the solution containing sand particles and the salt solution. Then the sand will remain on top of the filter paper. Then we can collect the salt solution. So the answer was filtration. So that was the expected solution. Right. For the second part, ethanol solution and water. Right. So the substance we are talking about is ethanol and solution water. Okay. So these are all liquids. So when we separate liquids, the first thing that should come into your mind is two methods. We have got the fractional distillation. We have got the decanting method, right? But when we talk of decanting, we'll be talking about those liquids with the different densities, so that we can pour into another container, and the remaining liquid we can collect it easily. But in this case, we don't use that method. So we deal with the boiling points, right? So which means the most suitable method is fractional distillation. Fractional distillation. So that would be our solution. Then we managed to answer the first part on part A. Then we are going to answer the part B. Right? It's saying table 1.1 is an incomplete table showing two ions and their subatomic particles. Right? Some people, when they see some of these questions, they panic. But you don't have to panic. We are given a table. So if you are given a table, just focus on what is given and do what the question is saying. So the table is here. We have got the ions. We have got the number of protons, the number of electrons. So from the elements and atoms and compounds, that's the first topics of chemistry. So we will be making use of a periodic table, but this is just basic. We have got a nitrogen ion and the hydrogen ion. Then we need to find the number of protons in the nitrogen ion. So this ion, like for example, in its ground state nitrogen, it has got 7 electrons. So we can start to fill the part of electrons. In its ground state, it has got 7 electrons. Right? This information, we get it from the periodic table. Then after it gains 3 electrons, which means we are saying plus 3. Because to form this anion, the N3 minus, is by gaining 3 electrons. So 7 from the ground state, then plus 3 to make it 10. So that's how we find the number of electrons in the nitrogen ion. So there are 10 electrons. Right. Then for the hydrogen ion, the first thing is to consider the ground state. Right. In its ground state, hydrogen, it has just 1 electron. Then to form a positive charge, a cation, it means it lost that electron, which is 1. So we are saying from ground state 1 electron, then forming a plus charge, it means loss of an electron. So 1 minus 1, this gives us 0. So the answer was 0. So that's how we get the solution there. Then for the number of protons, right, the number of protons does not change, because when substance form ions, the only particles which participate are the electrons. The protons remain in the nucleus, they don't take part. So meaning to say, we just take the number of protons from the ground state of that substance from the periodic table. So nitrogen has 7 protons, like the proton number, that's the number of protons, so it's just 7. Hydrogen, 1 proton. Right, so we managed to answer the part B. Right, so meaning to say, we collected these 4 marks. You don't have to lose these marks, it's very important for you. Right, there is chemical bonding. Right, this part. So the part C is saying draw a dot and cross diagram to show the bonding in ammonia. So whenever you see such questions, the first thing to do is to smile, because this is very, very easy. Like, okay, we have to hurry up. Right, so we are saying in ammonia, we are going to show the dot and cross diagram for the bonding in ammonia. So ammonia, you have to know the chemical formula, which is NH3, meaning to say the nitrogen atom is surrounded by 3 hydrogens. So I am drawing 1 atom of nitrogen on center. Then I will surround this atom with 3 atoms of hydrogen, like this. So because the only shells which take part in the reaction, in the bonding, are the outermost shells. So I will just show the outermost shells, because these are the shells with the valence electrons, the electrons that participate in chemical bonding. So after drawing the shells, I label the atoms. So these are the hydrogen atoms, hydrogen atoms, hydrogen atoms. Then here we have got the nitrogen atom. So each hydrogen atom share 1 electron, like this. Then nitrogen also contributes 1 electron. 1 electron from hydrogen, 1 electron from nitrogen, 1 electron from nitrogen, then 1 electron from hydrogen. Then for the hydrogen, it's okay. But for nitrogen, it has 5 electrons in its outermost shell that you have to participate, or that can take part in bonding. But here it shared 3 of its 5 electrons. So meaning to say 2 are remaining. So those 2 we can just show them here. So we are done. So we collected 2 marks again. Then right, for the number 2, we are given a diagram. So don't panic whenever you see a diagram. You just have to focus on what is there and deduce what you should do. Then it's saying fig 2.1, this one shows a zinc plate placed in copper sulfate solution. So this is our zinc plate as labeled here. Then we have got the copper sulfate solution in this maybe a beaker. Then this shaded is showing the brown coating, right? So that's the information we have. Then there is a question on part A, item 1 is saying identify the brown solid deposited on the zinc plate, right? So we have a question, we have a diagram. So we have to understand the diagram and to relate to this question there so that we can answer. So our answer, we shall write it on this part. So the brown solid, for us to identify, we have to know what is happening here. So we have got the zinc plate, we have got the copper sulfate, but in the copper sulfate solution, there are copper 2+ ions. The copper 2+ ions. Then for the zinc, it's just zinc solid. Then from the reactivity series, we see that zinc is more reactive than copper. So what happens here? Zinc can readily reduce the copper 2+ ions to copper, right? To copper. Then zinc will form the zinc 2+ ions. But this information is not asked, but we just know that. So meaning to say, when they place the copper sulfate solution here, these reactions are occurring. But this solid is this one which is being deposited at the zinc plate here. So this shaded part is the brown coat is showing the copper being deposited on the zinc plate. So that's what we are going to answer. So this is just the copper solid. Copper solid. So that's the substance being deposited on the zinc plate. Right, the other question is saying write a balanced chemical equation for the chemical changes taking place. Right. It now is, because we know what is happening. So we just want to write a balanced chemical equation for the chemical changes. So I said we have got zinc, which is a solid, right? Then in copper sulfate solution, we have got the copper 2+ ions. So I can say plus the copper 2+ ions, because these are ions taking part in the reaction. Then this gives us, I said this will reduce the copper 2+ ions to copper solid plus. The zinc solid, after reducing this one, it means it has lost its electrons, so it will form the zinc 2+, which is in aqueous solution. Or else someone can say zinc solid plus copper sulfate. It's the same. Then to form here, we just form copper, the solid. Then plus zinc sulfate, aqueous. So these are just the same equations, but we just mentioned the sulfates because they are there, but they don't take part in the reaction. So the zinc 2+ ions can combine with the sulfate ion to form the zinc sulfate. So either you can write this one or this one. It's still okay. Right. So that's how we take these 2 marks. Then for the part 3, it's saying state the type of reaction which occurs when zinc is converted to the zinc 2+ ions. Right. As we shown here. Right. Alright. We are saying zinc to zinc 2+ ions. Zinc was converted into zinc 2+ ion. So the type of reaction, right? Okay, so we are saying this one is for the types of reactions. We should know that we have got different types of reactions. Like we have got neutralization reactions, we have displacement reactions, and so on. So in this case, copper was displaced from its compound by zinc, as we see in this equation. Right. So it's a displacement reaction. Displacement reaction. Okay. Right. Then we now move on to part B. There is another diagram. Okay. So it's a fig 2.2 represents a method used to test for a gas produced when calcium carbonate is heated. So when we heat calcium carbonate, okay, there are some chemical changes that take place. Right. As we see in this diagram, we are heating this hard glass test tube containing calcium carbonate. There is a pipe which is connected to a test tube containing lime water. Right. So what is going to be produced here will be transported to this test tube. Okay. So the person is saying, describe what happens when calcium carbonate is heated. So when we heat this calcium carbonate here, calcium carbonate is a formula of calcium carbonate, solid, then we heat. Okay, then we produce calcium oxide plus, this one is a solid, plus a carbon dioxide, like this. So that's the reaction that takes place after we heat, because it's not stable under high temperatures. So when we heat, this reaction takes place. So this one should know it in our mind. Then we want to describe now. So this reaction is showing that this calcium carbonate decomposes. So the first thing we say, decompose. So calcium, we can write the chemical formula. Calcium carbonate, solid, decomposes to calcium oxide, a solid, and the carbon dioxide is liberated. Yeah, that is what is happening here. Then what will happen after this thing? These substances are produced here. So only the gas will be transported to the lime water in this test tube. So the carbon dioxide will enter the test tube with lime water. Right. Then we can say lime water 10 milk. Right. So this lime water will turn milk or become unclear, something like that. So that is the reaction or the chemical changes that take place. So the first thing was to say calcium carbonate decomposes to form calcium oxide and carbon dioxide. Then the second thing is that the carbon dioxide released will turn the lime water to milk. Right. So that's what is expected on that part. So we can take the 3 marks. Then the last one, but not the least, is saying state the acid base nature of the product that remains in the hard glass test tube, this region. So we have seen that the carbon dioxide produced here will be carried to this test tube containing lime water. but we have not mentioned about the calcium oxide. So meaning to say, this is the substance, the solid that is going to remain in the hard glass test tube, right? So, but we are not asked to state it, but to state the acid base nature. Is it a base? Is it an acid? Is it amphoteric? All right. So this carbon dioxide, calcium oxide is basic. So it is, no, we should not use it is. We can use calcium oxide is basic, or it is basic. Okay, so we can write is basic or alkaline. Right, so those were the expected solutions. So that's the end of our paper, and if you found this revision helpful to you, you can subscribe so that in the next videos you benefit a lot, because it's coming.